Hi everyone, I wanted to make a quick video for you guys on how to deal with standard deviation and standard error, and more so how to do the standard error bars on a graph. I apologize, you can probably hear the Mr. Softy truck. But anyway, so I have a data set here, and the question is, do leaves grown in full sun have a significantly larger width than leaves grown in the shade? So I have in my table here the width of the leaves grown in the shade and in the sun, and measured in centimeters. All right, so the first thing that I would do is calculate my standard deviation. Now that takes a little bit of time to do. So admittedly, I'm not going to sit here and do it by hand for you. I've done it already by hand, and I have a picture of it, but I'm going to walk you through what it takes. So standard deviation formula, if you're looking at it on the screen, here's the sum, right? The sum of the data point minus this stands for average, this x bar squared. So you have to go through and do that first for each data point. So starting with the shade, so 5 is my first data point, I subtract the average or the mean, so you get that right by adding up all these numbers and dividing by 5, you get 16.4. That gives me my deviation, I square it, okay, and that's my deviation squared for the first data set. Then I go to the next one, 12, right, 16, 21, 28, so on. I add up all these deviations and I get 305.2 after I go through and do that whole process, okay? So my standard deviation is the square root of the deviation squared, all summed up, so 305.2, divided by the sample size, that's what n stands for, sample size, minus 1. So in this case, I have 5 leaves in my sample size, so 5 minus 1 is 4, square root it. So my standard deviation for the first data set is 8.73. I would repeat that exact same thing for the sunny leaves, starting with the first data set of 2, 5, 15, 32, and 10, subtracting the average from all those data points and squaring it, and then I get all of my values, I sum or add them up, divide the sum of all those deviations, divided by the sample size minus 1 and square rooted. The second data set has a standard deviation of 11.82. Now this is pretty time consuming to do, and I said this in class and I'll say it again here. It is highly unlikely that you would have to do this on the AP exam. It is more likely that you would be given this information and then you'd have to know what to do with it next. But on the off chance that you are ever asked to do this, this is how you solve for the formula. Okay, so that's the standard deviation. Now, you need the standard deviation in order to calculate the standard error of the mean. So standard error of the mean, you'll see that the first part of the formula is a little s. That little s is standard deviation, okay? So standard deviation divided by the square root of the sample size. So for the shady leaves, we found our standard error, and for the sunny leaves, found our standard error by taking, again, the standard deviation divided by the square root of the sample size. That gave me this number. All right, that's for the sunny leaves. Or this, yes, I didn't write out the math for this one, but it would be the same thing. It would be the standard deviation, so 8.73, divided by the square root of the sample size, which in this case is 5. Okay, so I've got my mean for both data sets. I've got my standard deviation for both data sets, and now I've gone through and I've done the math for my standard error for the data sets. Now, often you're going to be asked to plot error bars on a graph, and usually when you're doing that, they're asking you to plot your bars 2 times the standard error of the mean. So here it says plus or minus 2 SEM. SEM stands for standard error of the mean. So to figure this out, all I did was multiply this number by 2, got 7.8, multiply this number by 2, 10.59, okay? So this is what I'm going to use now to graph my standard error bars. I'm going to show you how to do that next. So here's my graph. I'm going to set up my independent variable on the x-axis. I've got shady and sunny leaves. My independent variable will be the amount of light in this little experiment. The y-axis is going to have the average size of the leaves, all right, measured in centimeters. So the first thing I'm going to do is plot my averages. Oops, sorry. First thing I'm going to do is scale my graph, right? First thing I'm going to do is plot my averages. So my shady leaves had an average leaf width of 16.4 centimeters. That's just going back from my table on the last slide. And my sunny leaves had an average leaf width of 12.8 centimeters, okay? So that's first, just drawing your bars. Easy enough, right? The next thing we're doing is the standard error bars. To create your standard error bars, you need your standard error of the mean times 2. So that number I calculated last on the last slide. I go up from the standard the mean of the data set, and I go down from the data set whatever that 2 times the standard error of the mean was. So for the first data set, the shady leaves, I was going up from the mean 7.8 and down from the mean 7.8. That was my standard error of the mean times 2. So I add 16.4 plus 7.8 and I get 24.2, and that's the top of my error bar. Then I go down from the mean 7.8. That would be 8.6, and that's the bottom half of my error bar. So that's my first error bar. For my sunny leaves, or the leaves in the sun, my standard error of the mean times 2 was 10.58. So I add that to my mean. I go up 10.8 and I go down 10.8. 10.58. Up 10.58 is 23.4. Down 10.58 is 2.2. All right. And that's it. That's how you draw your standard error bars. It's pretty simple, but there's a lot of math to kind of get you to that point. And then the last stage of this is interpretation. So looking at these error bars, there is significant overlap between these error bars. There's a huge area here where these bars overlap one another. So my conclusion that I draw from that is because there is overlap between the error bars, we say there is no significant difference between the width of the leaves that are grown in the shade and the width of the leaves that are grown in the sun. And again, looking at this with my error bars overlapping, that's what I would conclude about these two data sets. It doesn't seem to impact the width of these leaves, whether they're grown in the sun or in the shade. All right, so that's how you do standard error bars. I hope that helps. We're going to be doing more practice in class, but I know we didn't really get a chance to go over this in detail yet, so I just wanted to make this quick video for you guys. Okay, that's it. I will see you tomorrow, or see you around.